Okay, so now we're ready for the notes video. So hopefully before you've already watched the visual aid video before you watch this one. If you haven't watched the visual aid video first, I recommend you go watch it first and then come back to this one, because I'm going to refer to what I've talked about in the visual aid video. I'm going to refer to it in this video. Okay, because this is just the notes video. So, as I said in the visual aid video, there were 4 special properties that we looked at. Now, they're actually split into 3. I can't even count 3 theorems, but the 4th one kind of goes along with this one, so I just stuck it in here. Okay. So the first one we talked about was the opposite sides. So I've kind of wrote it as a theorem, so I've started it for you, and then we'll just add in the part that we are really focused on. So if a quad is a parallelogram, then first one we talked about was opposite sides. So we'll say the opposite sides are congruent. And so we could, if we wanted to, we could mark it up like this. Okay, so remember, tick marks mean congruent. Okay, arrows, we could add arrows here too, but arrows mean parallel. So if I'm talking about congruent sides, then I need to put tick marks. All right, and then if you wanted to, we could list them out. So we could say AB is congruent to CD, that would be the bottom. And then we could say AD is congruent to BC. So this is one pair of opposite sides, this is the other pair, and they are congruent. In other words, they're equal. Okay? Second property deals with angles. So the first one we looked at was if a quad is a parallelogram, then the opposite angles are congruent. Okay? Let's scoot that up just a little bit. So in my parallelogram over here, I could say that this angle, don't know what it is, but I can give it one angle arc, and the one across from it, I don't know what it is, but I can also give it one angle mark because I know they are congruent because it's a parallelogram. And then these two, we don't know what they are, but they will get 2 angle arches, because they're congruent to each other, but they're different from the other 2. Okay, so we could say that angle A, so A is right here. Who's across from him? That's angle C. And then angle B would be congruent to angle D. So that's our pairs of opposite angles. Okay, the third property we looked at for a parallelogram was about the angles that are on the same side. Now remember, in the visual aid video, I had actual measurements for you, like they were 156 or 120 something and 50 something, I think. I don't remember the exact measurements now, but when you added them together, they equaled 180 degrees. That meant they were supplementary. So we're going to say if a quad is a parallelogram, then the same side angles are supplementary. Remember, supplementary means they equal one. Oops, can't say that. They equal 180. When you add them up, they equal 180. So for example, we could say A and D. So we would say the measure of angle A plus the measure of angle D equals 180. And that's just one example. You could list all the way around if you wanted to. I'm just putting one down for you so you can see it. Okay? The last property was about the diagonals. So remember, when the diagonals meet each other in the middle, they cut each other in half. So we would say we could put a tick here and a tick here, and then 2 ticks here, 2 there. Because they're different measurements, okay? Like this one with 1 and this one with 2, they're different measurements. But the ones on the same diagonal, they are the same. So that's why they're marked up like this. So we say if a quad is a p-gram, then the diagonals bisect each other. And remember, the word bisect is fancy for cut in half. And each piece is equal in length. So we would say, let's start with AO. AO is on the same part as CO. So AO is congruent to CO. And in the same way, BO is congruent to DO. Okay? So those are the 4 properties about parallelograms, and you need to try and remember these as best as you can. Okay? So you got opposite sides congruent, opposite angles congruent. Same side angles are supplementary. Diagonals bisect each other. You need to try and remember those as best as you can. Because now what we're going to do is, now we understand the properties, we're going to use them and find some missing sides and angles and solve some equations to get there. All right, but we're going to start with just some plain numeric examples. So I've given you a parallelogram with 2 sides labeled and 1 angle. That's all you need to figure out the rest of them. That's what we're doing here. So AD is right here. That's a side, so look across, and it's 8. Easy as that. These 2 are opposites, so they have to be the same. Same for DC. DC is opposite from AB. AB is 15, so DC also has to be 15. Measure of angle A. Angle A is right here. Notice it is on the same side as the 68. So 68 plus whatever this one is going to be 180 degrees. So to get this one, I'm going to have to do 180 minus the 68 to get what I need. And if we do that, that'll be 112 degrees. So if we wanted to, we could put 112 right here. That was 8, that was 15. You don't have to mark up your picture like I am, but if it helps you, go ahead and do it. All right, angle B. Angle B is across from the 68, so they have to be the same measure because opposite angles are congruent. And then the same for angle C. Angle C is across from A. A was 112, so C has to be 112. And that's it. It's that easy. As long as you know the properties and you have all the information, this is a breeze. Okay, we have another one. Find these measurements. So notice I have 2 sides labeled, and I have a piece of a diagonal labeled. And they told me RT. So look at RT. That's an entire diagonal. Keep that in mind. All right, UT. Where's UT? Right here. That is a side, so look across. That's 27. ST is another side. Look across. 18. That is a terrible 8. VS, right here, that's another piece of the diagonal. Now look below it. UV is labeled with a 7. And then SV is on that same diagonal. So these two pieces have to be equal to each other. So we're going to say that that one is 7. All right. Now, next one is VT. VT is right here. Well, how do I find it? I don't know what RV is. This is where this comes into play, because they told you that RT, the entire length, was 30. And we know that when the diagonals meet, they're bisected, they're cut in half. So if the whole thing is 30, and I'm needing half of it, I need half of 30. What's half of 30? 15. 30 divided by 2 is 15. That's it. That's all you do. Okay? So now we're getting to the equations territory. So when we get into the equations territory, you first have to recognize what the property is, what the property says, and then set up your equation correctly. Okay, so look at what we've got here. We have opposite sides because they are across from each other. We know that opposite sides are equal, congruent to each other. That means that this expression has to be equal to this expression. So we're literally going to set those equal to each other. And solve for the x. Now, my trick is, if you haven't had me before, I tell all my kids this. When you have variables on both sides, the easiest thing to do is to move the smaller variable first. So between 19 and 11, 11 is smaller, so I'm going to move that one first. That is my personal choice. You don't have to do that if you don't want to. I just think it makes your life easier if you do it. Now that we moved the x over here, this 31, he's got to go to the other side. So then we'll have 32 equals 8x, because 1 plus 31 is 32. Divide by 8, divide by 8. 32 divided 8, x is 4. That's it. Okay? Hopefully not too bad so far. So now this is where like the step up. So now you'll have some problems where it's just basic, where you set it up, find x. These ones, you have to find the x first, and then go plug x back in to get an actual measurement. Okay, and I want you to be able to do both. Just find x, and then find x and go plug it in. Okay? So let's look what they told us. NS is 2x plus 7. So I like to go find NS and actually write that down. So 2x plus 7. Just like that. That is kind of blurry. There we go. SQ is 5x minus 23. SQ is 5x minus 23. They want us to find NQ. So look at where those expressions are at in the picture. They are on the diagonal. Well, what do we know about pieces of the diagonal? So think back to the visual aid video and what we just talked about in this notes video. We know that they are congruent. They're equal to each other. So we're going to take those and set them equal to each other. And we'll solve for x. So move the smaller one first. So 7 equals 3x minus 23. Now we have to add the 23. So then 30 equals 3x divided by 3. 30 divided by 3, we all know is 10. So, we got x is 10. But that does not answer the question, because look what the question says. Find NQ. NQ is the entire diagonal. So what we need to do now is to go plug the 10 into both of these, and then we'll add them together, because these are the halves, and two halves together make the whole that we need. So NS was 2x, which was 10, plus 7, and when we evaluate that, we get 27. SQ is 5 times x minus 23, and when you get that, it's 27. As a side note, notice that these two are equal, which is what we planned for. If they're not equal when you plug your x in, you've probably done something wrong. You need to go back and rework it. Okay? So now we have the two halves, and you add those two halves together, it'll get the whole. 27 plus 27 will be 54. And that's that problem. So this one was kind of a multi-step. You had to get the x first, go plug it back in, and then add the two answers together at the end. What you could have done instead, because some people like to think this way, is you could have just plugged it into one of these, so got one of the 27s, and then just times it by 2 to get the 54. If you want to think of it that way. Either way is fine with me. Okay? Similar setup for the next problem. Solve for x, find the measurements. So look at where these measurements are at. Those are opposite angles because they're across from each other. And we know that the opposites are equal, so we're going to set those two equal to each other. Move the smaller x first. Now we'll add the number. So 2x equals 26 divided by 2. X is 13. So now they want the measure of angle A and the measure of angle B. So just for note, if you see the little M in front of an angle, that means measure. They want the actual angle value. So you have to go plug the X back in. So angle A is right here. It was the 6x minus 15. So 6 times 13 subtract 15. And when you type that into a calculator, you should get 63 degrees. Now look at this one. They want the measure of angle B. Where's angle B? It's up here. And there was nothing written there. Well, what the crap? What are we supposed to do? What do we do now? Remember that A and B are on the same side of the parallelogram. What do we know about same side angles in a parallelogram? We know they're supplementary. So the 63 plus whatever that is equals 180. So we were going to do 180 minus the 63 to get angle B. And when you do that, it'll be 117 degrees, 117. So watch out for those kind of problems. They might have you find an angle that wasn't explicitly given to you. So once you plug the X in to get this one, then you had to turn around and use it to get this one. Sometimes they'll do that to you. Okay, last one. Solve for X, find the measurements. So look at where these angles are at now. They are no longer across from each other. They're next to. They're on the same side. Same sides are supplementary. They add up to 180. So I'm going to take those two expressions, 3x plus 5, plus the 8x minus the 12, and equal it to 180. And now we'll solve it. We need to combine like terms first. So 3x and 8x make me 11x. 5 minus 12 is minus 7. Now we can solve. So add 7, 11x equals 187 divided by 11. And when you do that, you should get 17. And now we want P and Q angles, so this time we have both of those. And so we'll just plug them in. So 3 times 17 plus 5. When you evaluate that, it'll be 56 degrees. This one was 8 times the x minus 12. When you evaluate that, you will get 124 degrees. And as a way to check yourself, add those two together. What is 56 plus 124? And it should be 180. Okay, that's it. That's all about properties of parallelograms. So make sure we watch both the videos I've made for you, the visual aid and the notes video, and then you complete your homework assignment. I think there's just 15 problems, and I split it up into 3 sections. There's one section that is just numbers, just numerical. There's a section where you just find x. Then there's a section where you find x and go plug it back in. Okay? And as always, if you need help, let me know.